Okay, as promised, here is the next lecture, the second lecture in a three-part series on elasticity. In the first lecture, I just went over the basics of the chapter, hit the highlights, pointed some things out with respect to the four basic measures of elasticity that we as economists tend to use. So for this lecture, what I would like to do is to actually work through an example. The best way to learn economics is to do economics, and so that's what we're going to do. We're going to go through the different calculations, showing you how to actually perform these calculations, how easy it is with respect to the price elasticity of demand, recognizing that the same basic formula, this midpoint formula, arc elasticity, is going to be the same for cross price. The only difference in cross price is going to be that it's the price of one good and the quantity of another. So it's the same exact formula, it's just P of X and Q of Y. So that's easy enough. With income, we're going to be replacing price with income. The quantity stays the same, but the price variable now becomes income. It's the same formula, same methodology, everything is the same. With supply, the good news is it is still price and quantity, but it's going to be quantity supplied instead of quantity demanded. But it's still the same exact formula. It's just going to be QS instead of QD. So the good news is once we get really good at doing the price elasticity of demand calculations with the midpoint formula, you are able to perform elasticity midpoint or arc elasticity calculations for cross price, income, and elasticity of supply as well. So that's good news. Just practice. It just takes some practice. That's all. All right, so what I'm going to do is I'm going to share on the screen here like I usually do. I'm going to share the handout. Notice that your handout is going to be blank. You should print it out ahead of time. Follow along as I go through this. If I do go a little quickly, feel free to stop, pause, rewind, do whatever you need to do to make sure that you're getting all of the necessary information. You're understanding how I go from step 1 to step 2, for example. As I go along, record your answers on your blank handout. That will be to your best advantage. I'm not posting the answers. I'm not posting this completed answer key. I don't want you to memorize the answers. I have posted the blank one so that you can work through and get the answers yourself by watching the video, following along, and then ultimately testing yourself. Go try it again. Print out a blank one as you're reviewing for the exam and see if you can do it, and then compare your answers to the original one that we did. All right, so here we go. So let me share my screen. Share screen. Here we go. I already have this prepared for you. Here is the handout. We're going to start with the price elasticity of demand along a linear demand curve. We're going to plot this linear demand curve, demand for hamburgers at Disney World. If you've ever gone to Disneyland, Disney World's in Florida, Disneyland is in California. I'm from the Michigan, the Midwest, and we would go to Disney World quite often, especially in the winter. Winters in Michigan are rather harsh, and we would love to escape in January, February, head down to Florida and go to Disney World. So I have lots of experience with this. But once you are trapped, you are inside Disney World, you pretty much, if you get hungry, have to buy their food, which can be a little bit more expensive than if you were buying a hamburger at McDonald's, for example. But anyways, here's a demand schedule, hypothetical demand schedule for hamburgers at Disney World. Notice the way I've set it up that it is in fact a linear demand curve. You can see that because the price ranges are all 2, from 10 to 8 to 6 to 4, and the quantities are all 100. So as my price drops by $2, my quantity demanded increases by 100. Each $2 interval is associated with 100 increase in quantity, okay? So there we go. This is given to you on your handout. What I've done is I've taken that information and I've plotted it. That's the first thing we do in economics. We want to see what it looks like. We're very visual. We love our graphs and seeing what's going on with the depiction of this in space like this with the XY coordinate system. It's really helpful. So I've plotted this demand curve, P on the vertical, Q on the horizontal, and now I've just labeled each point A, B, C, D, E, each combination of price and quantity. So the first row here at a price of $10, nobody would want any. That's right here at point A, and so on, all the way down to point F, which is if they were giving away the hamburgers for free, 500 people would want free hamburgers. Okay, this is just a demand curve. This is not a market model. Obviously, as I've mentioned before, market models must have both supply and demand. This is just a demand curve. We're just looking at the consumer side of things, okay? So what we want to do is we want to use this price elasticity of demand formula, in particular, the midpoint formula, the arc elasticity as it's called, because we have both the prices and the quantities. We have the original price, which we're going to assume is farther up and to the left as we work our way down this demand curve. And then the new price is going to be $2 lower and obviously 100 units further along the demand curve to the right. And so in this case, when the first part of the question says, calculate elasticity of demand between $10 and $8 and interpret, I added, yours might not say this, that's going to be represented by a movement from point A to point B along our graph. Going from A to B, my price is falling from 10 to 8, and correspondingly, my quantity is increasing from 0 to 100. And so what I've done, at least on this first calculation, is I've written out the midpoint formula for you. The elasticity of demand is equal to the change in quantity over the change in price. And again, you listened to that first lecture, so you know that those triangles are actually the Greek letter delta, and delta represents change. So when I see those, I read this as change in Q over change in P. And we're multiplying that fraction, that ratio, by the average P over the average Q. And that's how I read this language. When there's the bar over the variable, that denotes we're taking an average. So the average of the two prices, in other words, halfway between them, and the average of the two quantities, halfway between. If you need to, I wrote out for you on this first slide. I did not continue to do this on the subsequent slides, so you may have to rewrite that yourself, but this is just a note to remind you. How do we find the change in Q? Well, we take the new value of Q and subtract the old value of Q. So Q2 minus Q1, how much did Q change? That's going to be my change in Q. My change in P is the same thing. It's my new price minus my old price, recognizing that as we go along, because we're talking about a demand curve, one of the two, either change in Q or change in P, is going to be negative. One of them is going to be positive. So as you can see by looking ahead, spoiler alert, these values are always going to be negative. Elasticity of demand is always negative. When we go to interpret and assign the range of elasticity, elastic, inelastic, unitary, to that value, give it a label, we then take the absolute value. We just look at the magnitude, in this case, the 9. All right, but spoiler alert, let's go back and see how we got that minus 9. So what I did was, in the second step, I replaced these 4 unknowns with what we know. And so moving from A to B, you can see that my quantity went from 0 to 100. So my change in quantity is plus 100. So I put that in there on the top of this first fraction. The change in P, though, went from 10 to 8. So my price fell by $2, negative 2. Notice, elasticity of demand, one of these will be positive, one of them will be negative. If you're walking down the demand curve, it will be your price that's falling and your quantity demanded that's increasing. But you don't have to always walk down the demand curve. You could go from D to C, for example. There's nothing stopping you from walking up a demand curve, okay? So I've got this first part. Now the second part, I'm going to multiply this fraction by this other fraction that says take the average of the price. Notice this is not a typo. Sometimes students think, oh, the Q is on top. The Q must be on top over here. Wrong. The P is on top on the second one. The Q is on top on the first one. But the average P is on top of the average Q. So they're opposite. People will flip those just because it's normal. Oh, Q goes on top. No. Make sure you're paying attention, following along, and applying the formula exactly. So in this case, the average P, halfway between 10 and 8, I don't even have to add them together and divide by 2. I just know halfway between 8 and 10 is 9, right? I can do that in my head. If you can't, and that's okay. Some people have a more mathematically inclined brain. Mine is definitely, math is my first language. English is my second. But in this case, if you couldn't see that right away, that halfway between 10 and 8 was 9, you could have just added the two prices together. 10 plus 8 is 18, divided by 2 is 9. So you would have come out with the correct answer that the average price is 9. Okay? With quantity now, the average quantity goes in the denominator of the second part here. And so the two quantities were 0 and 100. I went from 0 to 100. So halfway between 0 and 100 is 50 if you needed to. 0 plus 100 is 100 divided by 2 is 50. So either way, if you need to use this formula to remind you, that's a little bit slower and clunkier for some of us, where our brains automatically can go, oh yeah, halfway between 0 and 100 is 50. Either way, I'm not judging. All right. When you multiply the top, 100 times 9, and the denominator, 2 times 50, we get negative 900 over 100. Reduce that, the zeros cancel out, and you'll get negative 9. So between the prices of $10 and $8, between the points A and B on this demand curve, the elasticity of demand is negative 9, no units, no percents, no dollars, no nothing. It's just negative 9. Okay, it's just a unit-free measure. We're going to take that, look at the magnitude, just the 9, and we're going to say that's elastic because it's greater than 1. If you're not familiar with these ranges, go back, watch the first video where I talked about the ranges and how to interpret these elasticities of demand. In this case, because the absolute value is greater than 1, we're going to assign the word elastic to it. Piece of cake, right? Here we go. Let's try the second one. We're going to work our way down this demand curve. So now when we move from $8 to $6, okay, from point B to point C on that graph, you should notice that the change in Q and the change in P are the same. Like I said in the beginning, for every $2 that I go down, 10 to 8 to 6 to 4 to 2, my change in P is $2. My change in quantity, 0 to 100 to 200 to 300 to 400 to 500. My change in Q is always going to be 100. So positive 100, my change in price, negative 2. This is the same. I highlighted it in red for you. Let's go back right here. 100 over minus 2. It's the same. And that's because the slope of a linear demand curve is constant. And as I pointed out in the first lecture video, go back and watch it if you need to remember this, right? That first part is not slope. The 100 over negative 2 is not slope, but it's actually the inverse slope of that demand curve. And because slope is constant, inverse slope is also going to be constant. So the cool thing about doing these elasticity of demand calculations is we go down the demand curve. If we're using the same intervals as we work our way down that demand curve, this first fraction is going to be the same in every calculation. Super cool. Then all we got to do is the second half, the average P over the average Q, and then multiply it out, right? Okay. And so that's what I did. I copied over the 100 over the minus 2. In this case, halfway, my average price, halfway between 8 and 6, obviously, is 7. My average quantity between B and C is 100 and 200. Halfway between 100 and 200 is 150. So that's how I got the average quantity. When I multiply the top and multiply the bottom, I get negative 700 over 300, reduces to negative 7/3. You could leave it on that as you want if you're a fraction person. Some people like fractions, some people like decimals. I'm very fluent in both. Those are equivalent expressions. And so in this case, I did put the decimal. Elasticity of demand is equal to negative 2.33. It's a little easier to compare with a decimal to a 9.0, which doesn't have a fraction. To a negative 2.33 if we have the decimal, okay? And in this case, because the absolute value, 2.33, is greater than 1, we're also going to slap the elastic label on this one. Continuing along, and I'm just going to move a little faster because I think you're getting the hang of it, right? I have all the answers here. You can go back, rework these, and double check, right? But from C to D now, my first part of the fraction is going to be the same. I wrote out the same equation, the midpoint formula. And I plugged in my 100 and my negative 2. Between C and D now, my price is between 6 and 4. Halfway between 6 and 4 is 5. So my average price is 5, right? And so then my average quantity in this case is between 200 and 300. So my average halfway between 200 and 300 is 250. Multiply the top, multiply the bottom, and I get negative 500 over 500. Well, that's negative 1, and that is super duper cool because that is now unitary. Go back to the lecture, go back to the book, and you'll see that when the absolute value of the elasticity of demand is equal to 1, when it's actually equal to 1, then we call it unitary elastic. So we found our unitary range between C and D on this linear demand curve. Alrighty, notice each time the number is getting smaller in magnitude. Okay, it's actually, if you have the negative number, it's actually getting bigger. But taking away the negative, the absolute values are absolutely falling from 9 to 2.33 to 1. The absolute value is getting smaller, right? We call that less elastic, right? So let's keep going. I can see where this is going. It's now going to become less than 1. We're now going to have a decimal, I would hypothesize, if we continue along the same trend. And if we look from D to E in this case, right, we have the same plus 100 over minus 2. We're dropping the price another $2, and we're increasing our quantity demanded by 100. So that change in Q over change in P is the same, that inverse slope there. But now between $4 and $2, that average price is 3. On the other hand, the average quantity is between 300 and 400. Go back and look if you're not sure. Look, D to E is between 300 to 400. Yes, I wasn't lying. And so that becomes 350. And when I multiply the top, multiply the bottom, I get negative 3/7. In terms of the decimal equivalent, that's negative 0.43. Okay, now this absolute value is less than 1. 0.43 is less than 1. So I'm going to slap on the label inelastic. Inelastic. And again, the absolute values of the elasticity of demand are continuing to shrink. So if I were to ask you to hypothesize, what would E look like? I think we can agree that it's going to be less than 0.43. It's going to get smaller, the absolute value. All right, so let's try it. So between $2 and $0, that's represented by point E and F on that demand curve. Same formula, same 100 over negative 2, but now between 2 and 0, my average price is 1. Between E and F on the quantity, the horizontal axis, between 400 and 500, the average is 450, halfway between. Multiply the top, multiply the bottom, you're going to get negative 1/9, and that's negative 0.11. The absolute value, 0.11, is less than 0.43. I was correct. Yay, love being right. And in fact, the 0.11 absolute value is less than 1. So therefore, I'm going to slap on the label inelastic. Pretty cool. So the lesson is, as we walk our way down the demand curve from higher price to lower price, increasing the quantity demanded along the way, what will happen is the elasticity gets lower. It becomes less elastic. It goes from big absolute values to small absolute values, okay? From big numbers above 1 to small numbers less than 1. And so what I did is I took that original demand curve, I just copied it from the first page, that original demand curve that I drew, and I added these little call out boxes to show you that the elastic region is up here between A and C. The inelastic region, and this is from the numbers that we calculated. How did I know this? I just took the words that we had assigned to the different values. D to E, E to F was inelastic, and we found that C to D was our unitary range. So again, you can see as you walk down the demand curve, you go from areas of more elasticity through the unitary elastic portion and then into the inelastic portion. And so that's where I want to end it. Hopefully now you have a better sense of how to use that midpoint formula, how to calculate your elasticities, and then how to interpret them, assigning them the label either elastic, unitary, or inelastic, reminding you that those terms, elastic, unitary, and inelastic, are only used for elasticity of demand and elasticity of supply. Those are not the same labels we're going to use for cost, price, and income. Go back to the first lecture where I talk about that to make sure that you know, in the first handout, as to how to apply the correct labels for cross price elasticity and income elasticity. All right, hope this is was helpful. Hopefully this will help you with respect to completing that first homework, and then ultimately the post-unit quiz and the exam on this concept of elasticity. I'm going to be posting another lecture that goes over the second handout on elasticity, and this one has some word problems where we're going to bounce around between the general formula and the midpoint formula so that we're pretty fluent in calculating elasticities, no matter how they're presented to us, whether it be a demand schedule like in this example or in the basis of a simple word problem. So hang on, look forward to that third in the three-part series on these elasticity lectures. All right, hope you guys are having a good day. I'll get that third lecture posted for you pretty soon. Thanks for coming. And then I need to figure out. Stop sharing and